Okay, let's continue our discussion of log functions. There are two log functions that are quite useful. One is the log function base 10. This is sometimes called the common log function. And sometimes this is written as the log of x. This is equal to the log base 10 of x. So notice, sometimes if you see the log written without a base, then you assume that the base is 10. There's a second one, which is written this way, ln of x. And this is called the natural log function. And this happens to be the log base e. Remember that funny number e that we talked about with compound interest, continuously compound interest? Well, that number is so important that if we look at the exponential function base e, it has an inverse function denoted by ln of x, so it has a special name. And this is the natural log function. Now, both of these log functions happen to look a little like this. Let's see if I can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is a little bit of the graph. This is the common log base 10 of x, equal to the log of x. This point here, notice this point here, this is 10, this is 1. So this is the point 10, 1. We find that the log base 10 of 10 is equal to 1. Okay, we'll take a look at that in a minute. For the natural log function, so that's 1, 2, that's right around here. And that is going to look like something like this. Where's 1? Oh, I'm sorry. 1 is up here. Let's see if I can get rid of, I don't know if I can get rid of that line or not. Yeah, I can. I'm going to change the color here. So the number e, 1, 2, the number e is, say, right about there. That's the number e. And if I take the log of e, I get 1. So my point should be here. And e squared is probably, I don't know. Let me pull out my calculator and see if I can come up with that. No, I cannot. My calculator is kind of dead. So I'm going to say it's probably out here somewhere. I don't know. Maybe around a little less than 8. But that's going to have a log of 2, so it should be right about there. So here's the graph of the natural log function. It has values bigger than the log base 10. And the log of e is just equal to 1. Why is that? So the log of e is equal to, let's say, z. We don't know. We want to find the value of z. Well, to write this equation here, the log of e is equal to z, is the same as writing e to the z is equal to e. And e is equal to e to the 1 power. Since the exponential function is 1 to 1, this implies that z is equal to 1. Okay? So from that, from here, we find that z is equal to 1. So that means that the log of e is equal to 1. Let's do some more of these calculations. Let's do a few more. Let's do this one. The log base 10 of 10 is equal to, I don't know, let's say I don't know. It's equal to z, okay? Well, what do we know? We know that 10 to the z power is equal to 10. Oh, so that means that z is equal to 1. So we get the log base 10 of 10 is equal to 1. All right, not so bad. In fact, the log base a, and I think we mentioned this, the log base a of a is equal to, we'll say z. This is equivalent to saying a to the z power is equal to a, and a is equal to a to the 1 power, and the exponential function base a is 1 to 1 and therefore invertible, and so z is equal to 1. So we have the important relationship that the log base a of a is equal to 1. Right? What if I have this? The log base 5 of 1 over 125, and I want to find that. That looks tough. So let's call this w. I don't know what w is. I want to find. So what I want to do is I want to find w. Okay. So what I'm going to do is I'm going to translate this equation involving the log function base 5 to an equivalent equation involving the exponential function base 5. And that equivalent equation is 5 to the w power is equal to 1 over 125. Look at what we're doing. We can almost do it this way. We can say, hey, here's the base, and here's the base. Then this goes over here, and this goes over here. Okay? So now what do I have? I want to find w. So what I want to do is I want to express 1 over 125 as 5 being raised to some power. Well, what do we know? We know 5 to the minus 1 is equal to 1 over 5. 5 to the minus 2 is equal to 1 over 5 squared, and that's equal to 1 over 25. Then 5 to the minus 3 is equal to 1 over 5 cubed, and this is equal to 1 over 125. So what we have is 1 over 125 is 5 to the negative 3 power. My exponential function base 5 is 1 to 1, and that implies that w is equal to negative 3. So we found that the log base 5 of 1 over 125 is equal to negative 3. Let's do another one. Let's try one like this. The log base x of 8 is equal to 3/2. Wonder what that is. So what we're going to do is the same thing. We're going to say, okay, we're going to transform this equation to an equation involving the exponential function base x. So what do? We have x, and what goes in the exponent spot on x? It's 3 halves, and this is equal to, well, it's equal to 8. So I have to find a number here, x, such that when I raise it to the 3 halves power, I get 8. Well, this is equivalent to saying x to the 3 halves raised to the 2/3 is equal to 8 to the 2/3 power. If I multiply this out here, this is x to the 3 halves times 2/3, which is equal to x, and that's equal to 8 to the 2/3 power, which is equal to 2 squared, and that's 4. So x is equal to 4. So we have the log base 4 of 8 is equal to 3 halves. Okay. What if I ask you to do this? What if I said graph the log base 2 of minus x? Well, now what I have to do is I have to first, this is what I failed to do before, I have to first ask, hey, what is the domain of the log function base 2 of minus x? In other words, what values of x can I put in here to make this meaningful? Well, we know we can't take the log of a negative number. The log function is only defined for positive numbers. So that means that the domain of the log base 2 of minus x is the set of negative real numbers. In other words, it's defined on the interval minus infinity to 0. Okay? So, here we have 1, 2, 3, 4, 5, 6, 7, 8. I don't know if I really want to go out that far. If I graph the log function base 2, this domain is the set of positive real numbers. So it's going to look like this. It has to go, the log base 2 of 1 is 0. And then the log base 2 of 2 is 1. The log base 2 of 4 is 2. The log base 2 of 8, I think this is 8, 4, 5, 6, 7, here's 8, is just going to be 3. So we have something that kind of looks like this. Okay. Well, all right, if I'm looking at the log base 2 of minus x, what do we know? We know that that's going to be the reflection of this curve about the y-axis. So it's just going to look like this. Oops. I think it goes on a little bit further here, but I can't get that on my graph, so we'll just do this. Okay. And that's it. So this point is minus 1, comma 0. This point is minus 2, comma 1. This point is minus 3, comma 2. Okay? All right. Take a look at some of the suggestions.